Hello, YouTube. Many of you might be aware that in recent history and currently we have issues with encryption and privacy protection. So, in many cases, in regards to privacy and encryption, people are on the basis that they have nothing to hide and therefore they do not really need that much privacy or that much encryption. So, if you stand on that end of the spectrum, I guess that's fine and you don't really need the information I'm about to give out to you. In the other case, if you're into like privacy and want to protect sensitive data to you, well, I want to give you a really easy and also very efficient and hard to break way of encrypting not only data but just messages and so on. So where does all of this start? I just want to give you a short background. Well, it starts roughly at World War II, where the German, or if you want to call them Nazi, or Axis, or Third Reich, is actually transmitting messages not only through submarines but between units in the tanks and airplanes and so on. And the Allies are basically intercepting the transmissions but cannot decrypt them. So they were calling, what is this Enigma machine that they're using? Enigmatic, like they could not figure it out. It was just a simple typewriter that pretty much the way the keys were ordered on the typewriter was reconfigured. Now, if you look on Wikipedia, what it says, it's pretty much a lot of mumbo jumbo and a lot of complications. Some part was even edited for sensitivity issues and so on, but all of this mumbo jumbo is pretty much useless if you figure out the idea that you just need to reassign the keybinds of your keyboard, right? So that's the basic idea of the Enigma machine. And how did the Allies figure it out? Or jokingly, it was because all the men were at war, so women were the new typewriters in those intelligence agencies, and they weren't used to sort of typing on the keyboard or on the typing machine, so they were actually looking at what keys they were pressing. So it sort of made them click that maybe if the keys aren't ordered the way you expect them to be, then you get a totally different message. So how does this translate into modern day technology and so forth? So how does all of this translate into modern day easy method of encryption and how you can do it at home? You pretty much need a keyboard or any way of pretty much reassigning the keybinds on your keyboard. It's efficient enough. In this case, I have a keyboard that comes with complementary software that facilitates all of the key binding assignments and so forth. So for instance, when I'm set on this setting, I type exactly what I see. I see and press 1 and it comes out as a 2 and as a 3 and so on. So as you can see here, there's nothing has been modified. Right, and when I change to this configuration, well, all the keybinds that are in red have been reassigned. So just to give you an example, in this case, my 1 key has been reassigned, redefined, or so on to number 2 key, and let's say my J key has been reassigned to my W key. So pretty much I've just in a way reconfigured the order my keys are aligned, the ones in red. So pretty much the T becomes an F and so on in this configuration. How does this translate into encoding and ciphering in the message? Let's say I want to type a message and I want to type what's up YouTube, right? And what comes out is with this configuration is exactly this mumbo jumbo pseudo, right? So you get pretty much a mumbo jumbo. Let's say I want to decipher what I typed. I just look at the keys I've typed and I press them. So I'm gonna press the J, the I, the U, the S, the O, the D, and then the P and the S and the F and the S and the 5, and then I press the H and my message is decrypted. All I have to do is pretty much type as I read something, or as I said, just type it as you would see it on the keyboard, and then when you see the enciphered messaging and you type the letters that you see here with the keyboard, it deciphers them. So pretty much one configuration of the keyboard not only like encrypts but also decrypts right away. And I mean, I don't know if you understand. I do not need to change the configurations. I just need to figure out one configuration that's different from the standard QWERTY or whatever you want to call it. And then like this configuration not only encrypts for me, but it also decrypts. And how is this done so that it's a strong encryption, for instance? Well, I would avoid using the spacebar, which delimits individual words in sentences, and also like symbols like hyphens and apostrophes, accents, and so on, right? That's one way. And also avoiding to use capital letters and repetitive patterns is another way. And how strong can potentially this encryption be? Well, you have to understand that you get a mathematical formula that's in the order of the number of keys that you reorder. There's like exponentially that many ways of reordering the keys as there is keys. So let's say there's about 100 keys I reorder on my keyboard. There's about let's say 10 at the power of 99 ways of reordering and rearranging those keys. So it's a huge way of encrypting, very powerful. And if you don't fall into the usual traps like using spaces or so on, like hyphens and stuff that like can give out some way of like deciphering the pattern, then it becomes a very strong encryption. And I mean, to decrypt that message, you of course need the way these keys are assigned, but there's different ways you can, let's say, remember or write down the way the keys are assigned. For instance, you can have what I have used pretty much here. You can have a mirrored distribution, like you pick it randomly the space between any two keys, right? And you start to spread out from that space like this, and then like that, and from here then like that, and so on, and then you re-enter here. So like I'm pretty much like spreading out, and if I want to recall that, then I just have to know that my F is becoming a G, and my G is becoming an F, and my D is becoming an H, and my H is becoming a D, and my S is becoming a, and so on. So for me to like reconfigure, let's say, the whole encryption pattern, I just need to know the breaking point of the mirror. That's one way. Another way is like let's change back to normal configuration, right? I just want like my 1 to equate K, and then my 2 to equate H, and then my 3 to equate T on the keyboard, and so forth. And then I would type my V to equate B. That's another way of writing it down. You know that the first one is like what you see on the keyboard, and the second one is what the key is binded to. And with this, it's, I'd say, like if you do it the smart way, it's pretty much unbreakable. The problem is always like protecting the key that deciphers and or reconstructing it because of like patterns that you use in creating it. So how is this supposed to improve all of that? Well, you know, if you believe that you're protected because you're using an HTTPS over an HTTP, and your data is safe now, and so on, or because you're using Tor, well, that's fine. I mean, I don't want to burst any bubbles and so on. But if you're like paranoid, like we might say I am, like, or so on, and you really like want to encrypt something sensitive or transmit messages that can be very easily deciphered once you have the key and very hard to decrypt, you can use this method. And it's not advertised, it's not publicized, because of the way it really like at the least complicates the life of intelligence agency in deciphering your messages, if they can even decipher it. And on another note, I want to leave you with something like, how do you say, just like put something out there in the air. So just to leave you on another note, like let's say you want to both have a way of like encrypting or decrypting low-level messages. So you understand that like having access to an image of this type can tell you pretty much like how to order keybinds and how to decipher messages. So in the case that I'm in a rush and I need a pre-made key to transmit information, you can transmit information about the keybinds that you have to assume in order to encrypt and decrypt a message in an image in itself, right? I don't know if you followed my logic. What I'm trying to say is that if you would see on the picture the way my keys are ordered, then you know how to assign your keybinds. And once you know how to assign your keybinds, well, then you know not only how to decipher, but how to encrypt, and we can communicate securely. So if I want to establish secure communication with you, I just need to communicate an order or a way in which you assign your keybinds. And from then on, once we both have that, well, we can establish a very strongly encrypted communication between us. So I want to leave you on that note and wish you good luck and good night.